In section 2.1, we did inductive reasoning. In this section, we are dealing with deductive reasoning. Deductive reasoning is sometimes called logical reasoning. No matter what you call it, though, it refers to the process of reasoning logically from true facts to reach a true conclusion. You do this in your everyday lives. Let's say it takes you an hour to commute to work. You have to be at work at 8 a.m. Therefore, you conclude that you better leave your house by 7 a.m. to get to work on time. This is an example of deductive reasoning. You took a set of facts, used some of that logic overflowing from your brains, and then came to a conclusion which was definitely true. Obviously, we will come across some deductive reasoning in more math-like settings, so you might have something like this. A right angle and an acute angle will never be complementary. Right angles measure 90 degrees. Acute angles must be greater than 0 degrees. So it would be impossible to add those two shapes together to make 90 degrees total. This is another example of taking facts, in this case the definition of a right angle, definition of an acute angle, and the definition of complementary angles, and using some logic to put it all together to come to a true conclusion. But let's do a quick diversion that will test your deductive reasoning also. Hopefully, though, it'll be a little bit more fun than the last slide. You may want to be ready to pause here so that you have time to figure it out on your own before I give you the answer. Are you ready? How many apples can a horse eat on an empty stomach? For the record, there is one answer. Are you curious? Have you got your answer? 1. Even if the horse eventually eats 50 apples, after the first apple, his stomach is no longer empty. This also used deductive reasoning. And hopefully, it was at least a little interesting. So let's look at the difference between deductive and inductive reasoning. With deductive reasoning, we use true facts. Those true facts might be definitions, statements we have determined to be true, postulates, the fact that before eating his first apple the horse had an empty stomach, etc., to come up with our conclusion. We couple those facts with logical reasoning to come up with a conclusion. Assuming our logic is sound, the conclusion we come up with is definitely true. There is no wiggle room. We base the conclusion on all true items, so our conclusion is also true. So what about inductive reasoning? With that, we use our inherent pattern recognition skills. We use common sense to see where the pattern is heading, and make a guess as to what will come next assuming the pattern holds. Because patterns can change and common sense often serves you well but not always, the conclusions you make are only probably true. You aren't basing your conclusion on rock-solid facts, so there is a bit of uncertainty with the conclusion. For the record, of the two types of reasoning, you do inductive reasoning more often in your daily life by far. So let's take a look at a couple quick examples. Kyle is running late for work. He needs to leave no later than 8 minutes from now. Kyle is really craving a couple of hard-boiled eggs for breakfast. Eggs. But he knows that they take 12 minutes to make. Kyle concludes that he can't have hard-boiled eggs for breakfast today and still get to work on time. Kyle used facts, how much time he had before he had to leave, how long eggs took to cook, and a little bit of arithmetic, to come to his conclusion. There is no gray area. His conclusion was definitely true. That's deductive reasoning. So now let's look at an inductive reasoning example. I am in a pickup basketball game and I am guarding Shaq. Unfortunately, he was also guarding me. The first 3 times I have the ball down low, he, quite easily, sad to say, blocked all 3 of my shots. I conclude that it would be more prudent to run around the 3-point circle and try to shoot over him rather than trying to score on him down low. For the record, that's a true story. I used inductive reasoning there. I saw a pattern, namely that every time I was down low and tried to score on him, he swatted me away like nothing. I concluded that continuing that pattern was silly, so let's try something new. Just to complete the story, I did start roaming around the 3-point line, and my next shot was a 3-pointer that I made over him. Now, my conclusion was only probably true. It may have been the case that Shaq was lucky the first 3 times. Not likely, but possible. And that staying down low was actually the better course of action over the long run. So I don't know for sure if it was correct, unlike if I had used deductive reasoning. But now for a trickier example. First, we have Kalinda, and she is doing her homework that has many problems trying to find the perimeters of equilateral triangles. She thinks for a moment before starting, and by using the definition of an equilateral triangle and perimeter, she concludes that every triangle's perimeter is 3 times the length of one of its sides. Now her homework will be easier to do. Josephine is doing the same homework set. After 4 problems, she notices that for 4 problems in a row, every equilateral triangle's perimeter happened to be 3 times the length of one of its sides. So she concludes the same thing that Kalinda did. so they both end up at the same place. Just how they got there was different. Kalinda's approach used definite facts to come to her conclusion, and her conclusion is definitely true. Josephine noticed a pattern forming. Based on that pattern, she made a conclusion, which happened to be the same as Kalinda's. We know from other sources that her conclusion was definitely true, but for Josephine, she couldn't absolutely positively know it was 100% true unless she used deductive reasoning to confirm her suspicions about the pattern. Hopefully these slides have given you a sense of the difference between deductive and inductive reasoning. And then we get to the law of detachment. It says this: if the hypothesis of a true conditional is true, then the conclusion is true. What? Does that say what I think it says? That seems pretty dumb. Let's look at an example. Let's assume this is a true conditional. If Luca is eating lasagna, then he is very happy. Okay, fair enough. So what does that law of detachment say? The law of detachment says that if we are given the fact that Luca is eating lasagna, then we can conclude that he is very happy. Hey, I have a new conclusion for you. I conclude that this is a silly law. Good grief, let's rename it. Or how about this? This is absolutely ridiculous. Have I made that clear? You don't need a law to tell you that you should be using an if-then statement like they are supposed to be used. If you know a conditional is true, and the hypothesis is true, then of course the conclusion is true. You absolutely won't be expected to know this law or its name. But in case you ran across it in the book, I wanted to mention it. Now all that being said, there is one little thing you need to be careful of. Let's say I have that same conditional that we are assuming to be true. If you are given that Luca is very happy, then you cannot make any conclusion. We won't know why he is happy. When given a true conditional, you must match the hypothesis, not the conclusion. Matching the conclusion without the hypothesis does us no good. Which brings us to the next law. It is a less dumb law than the law of detachment. And for the record, before we start, this is another law you won't be expected to know the name of. It is just way too archaic to be useful. But let's just see how it works. Do you remember the transitive property from algebra? It looks like this. If A equals B and B equals C, then A equals C. Does that look familiar? Hopefully. The law of syllogism is really the transitive property applied to if-then statements. Here's an example. First we have, if a figure is a square, then the figure is a quadrilateral. Now we have, if the figure is a quadrilateral, then it has 4 sides. You'll notice that the conclusion of the first line is the same as the hypothesis of the second line. That is building our transitive property. Based on this law of syllogism, you can also say that if a figure is a square, then it has 4 sides. So this law really is just a transitive property applied to logic statements. And that's all you really need to know. You just need to know that it is possible to do that. You really don't need to know the name law of syllogism. It is unnecessary. Just know that the transitive property can be used with logic statements.